In this episode, we are going to solve two examples on the superposition theorem. So our example is find the current through the 4 ohm resistor using superposition theorem. So this is our 4 ohm resistor and we are to find the current through it using the superposition theorem. So we have two sources, which is our current source and our voltage source. So our current source is 2 amperes and our voltage source is 20 volts. So with the superposition theorem, we are going to work with one source at a time and determine the current being produced by one of the source through the load resistor. So here I would like to consider the 2 ohm resistor or the 2 amperes current acting alone. So let the 2 ampere current source act alone. So we have the 2 ampere current source acting alone. So let's redraw the diagram and see how it is going to be. So in that way, we are going to short circuit the voltage source. So this is going to be our diagram. We have our voltage source. We are going to have our 5 ohm resistor. This is going to be the other resistor. So this is how our diagram is going to be without the voltage source. This is 5 ohm. This is also 5 ohm. We have the 4 ohm resistor and this is the 10 ohm. This is our current source, 2 amperes. So right now we are interested in the current passing through the 4 ohm resistor. So with this, we are going to find the effect of these two resistors. They are parallel to each other. So we are going to see how best they are going to act. Remember, the current is going to split itself into I2 here and I1. So this same I1 is the current going to pass through the 5 ohm resistor, because at this junction they are going to meet. Whatever gets to the 4 is also going to split itself into 2, and we are going to call that current also by a certain name. So I'll call this I prime prime and I'll call this as I prime. Are we okay? So now let's find the effect of the 4 ohm and the 10 ohm resistor as they are parallel to each other. That current we will find will be for the 2 ampere acting alone. So we now know that the 4 ohm is parallel to the 10 ohm and their effect is also going to be in series with this 5 ohm resistor. So this is what we mean. The 4 ohm resistor is parallel to the 10 ohm resistor and their effect is going to be in series with the 5 ohm resistor, this 5 ohm resistor. So first, let's try to work our mathematics. Now 4 by that is going to be 4 multiplying 10. So this is going to be, let's call this as R prime on 10 plus 4 plus the series 1 5, and this is going to be our R prime. Therefore our R prime, which is the effect, is going to be 7.86 ohms. That's for these 3 resistors, the 3 of them. As the 4 is parallel to the 10 and the effect in series with the 5, it is going to be 7.86. So this is what the diagram is going to look like. We are still going to have our current source here, and it is going to, this 5 ohm is still there. Now, the combined effect of the three resistors is also going to be in series or in parallel. This is going to be in parallel to the source. So this is our R prime, which is 7.86 ohm. And this is our 5 ohm. This is our 2 amperes. Please pay attention. We know that this current 2 amperes is going to be I2. From the first diagram, you can see that it is I2 here, and it is also splitting into I1 over here. So we want to find I1 first before we see how I1 is also going to split itself among the 4 ohm that we are interested in. So with this, the current divider rule is going to help us to get I1. So our I1 is going to be, we are going to use the 5 on 5 plus the 7.86 multiplying the current total, which is 2 amperes, and this is going to give us 0.778 amperes. So the current I1 coming from this junction is 0.778 amperes. Now, as it gets to the second junction, it is also going to split itself into I prime and I prime prime. So now we can also use the current divider approach to find the current that is going to be distributed among the 4 and the 10 from this current I1. Are we okay? So with that too, we can also use the current divider rule to find our current. The current through the 4 ohm is what we call the I prime prime. That is also going to be the 10 on the 4 plus the 10 multiplying the I1 current coming, which is 0.778, and that is going to give us a current of 0.557 amperes. What is the direction? The direction of I prime prime is upwards. So this current is an upward current. Now we know the current through the 4 ohm when the current source is acting alone. Let's find the current when the 20 volts is acting alone. So let the 20 volts act alone and see how we are going to make the analysis. So these two, we are going to open circuit the current source and use the voltage source. So this current source is going to be open circuited like this. So in that way, we are going to have only this part of the, we are going to use this diagram. Please, let's use this diagram. So it is, the current source is open circuited, so meaning it is out. And this is our diagram we are going to have. So we can see that this 20 is going to produce a current I. This current I is going to pass, everything is going to pass through the 10 ohm, and it is going to split itself when it gets to this junction, and there's going to be one here and one at the other side. But before we get the current I, we have to find the total resistance in the circuit and use the Ohm's law to find the I. We can see that these two 5 ohms, they are in series, and their effect is going to be parallel to the 4 ohm. And so we can see that this 5, the two 5 ohm resistors, they are in series, so we can add. And their effect is going to be parallel to the 4 ohm. Now we are going to get that. After solving for the 3 of them, it is also going to be in series with this 10 ohm resistor, 10, and that is going to be our R total. Are we okay? So this is going to be the 5 by 5, that is going to be 10, parallel to 4 ohm, and everything also in series with a 10, going to be the total. Now, the parallel aspect, that is going to be 10 by 4 on 10 plus 4 plus 10, R total. Therefore, it implies that our R total, when you punch this on your calculator, is going to be 12.857 ohms. So now with the Ohm's law, our I is going to be V on R, which is going to be the voltage. the voltage source that we are considering is 20. So that is going to be 20 volts on the total resistance, 12.857. And the current produced by the entire voltage source is 1.556 amperes. So now we know the current I produced by the voltage source. We know the current I produced by the voltage source. Let's try to see how we are going to distribute that current. That I, which is 1.556, is passing through the 10, everything. As it gets to the junction, it is going to split itself between the 4 ohm here. I'll call it, we already have I1, so I'll call it I naught, and the second one to be I double naught. Are we okay? So in order to find the current through the 4, we are also going to use the current divider rule. And the resistors at this part, they are in series. So their effect is going to be 10. So I naught current by current divider is going to be the 10 ohm resistor from these two on 10 plus the 4 that we are interested, multiplying the total current coming 1.556 amperes. The current is going to give us 1.111 amperes. And when you look at the current passing through the 4 ohms from the voltage source, it is a downward current. So we now have two currents, one from the current source, one from the voltage source. So we are going to consider which one to be positive and which one to be negative from our own analysis. So now let's find the effect and sum whatever we have to get our final answer. Let me take this off so that we can work the final solution. Now the total current through the 4 ohm is going to be, I'll consider the I naught to be positive. So we know I naught plus the one from the current source I prime prime. And that is going to be the positive one, 1.111 amperes, the downwards, and the negative one, 0.557 amperes. And with this, the total current passing through the 4 ohm is going to be 0.554 amperes by the superposition theorem. Let's look at the next example. Example 2. Calculate the current supplied by each of the battery and the superposition current through the 4 ohm resistor. So we have a circuit with two voltage sources and resistors connected. So we are to find the current by each of the battery acting alone, and we will also find the superposition current passing through the 4 ohm resistor. So straight away, let's look at how this is going to work. So our solution is, first I'm going to consider one of the voltage source acting alone. So I'm going to consider the first one, which is the 32 volt source acting alone, and I will short or open. This is a voltage source, so we are going to short circuit the 20 volts. We are going to short circuit it. So this is going to be what we have. Are we okay? So now this 32 volt is going to produce a current through the circuit. Are we good? And this current is going to divide itself here. So I'll call the current, the total current as I, and it is going to divide itself among the resistors. So that is going to be, we can call this IA and call this IB. But before we get the current I, we have to find the total resistance in the circuit and use the Ohm's law to find the current. So we can see that this 8 ohm is parallel to the 4 ohm, and their effect combined is going to be in series with this 2 ohm. So straight away the total resistance is going to be the 8 ohm being parallel to the 4 ohm and their effect being in series with the 2 ohm. So that is going to be 8 by 4 on 8 plus 4 plus 2. That is going to be, so this is our RT. It implies that our total resistance RT is going to be 14 on 3 ohm. Are we okay? So now by the Ohm's law, our current produced by the 32 volt, I by the 32 is going to be the voltage, which is 32 volts divided by 14 on 3. And this is going to give us a current of 48 on 7 amperes. So this is one of the solutions to our question. The current produced by the battery, which is a 32 volt, is going to be 4 on 7 amperes. Are you okay? But in order for us to know the current through the 4 ohm, let's perform the operation. As this current I, which is known, is going to distribute itself among the 8 ohm and the 4 ohm, let's use the current divider at this junction to know the current IA. So the current IA, which is a current through the 4 ohm, is going to be the 8 resistor, 8 plus 4, times the total current, which is 48 on 7 amperes. This is going to give us 32 on 7 amperes, passing through the 4 ohm if the 32 volt is acting alone. So we also have this intact. Now let's look at when the 20 volt is also acting alone. How is the diagram going to be like? Now from let the 20 volt act alone, meaning we are going to get our diagram this way. The voltage at the 2 ohm is going to be short circuited, and we are going to get this diagram. This is our resistor. The voltage is short circuited. This is our 8 ohm. It is intact, and our 4 ohm with our 20 volt current or voltage source. So this is the 20. This is our 4 ohm. This is our 8, and this is our 2 ohms. So this is also going to produce a current, let me call it I20, and the I20 is going to be known after we find the total resistance in the circuit. Here we can see the 2 and the 8 are parallel, and their effect is going to be in series with the 4. So we can say that our RT is going to be 2 ohm parallel to the 8 ohm and in series with the 4 ohm. So meaning this is very simple. We are going to get 2 by 8 on 2 plus 8 in series with the 4, and our R total, which is the total resistance, is going to be 28 on 5 ohms. Are we okay? So now we have the resistance, and the current I20 is going to be the voltage 20 on the total resistance, 28 on 5. That is going to give us a current 25 on 7 amperes. So the current also produced by this battery is also 25 on 7 amperes. Are you okay? But remember, this current is directly passing through the 4 ohm, everything, because there's no splitting, there's no junction. When the 20 volt is acting alone, all the current is passing through the 4 ohms, and that current is what? Upwards. And from the first analysis, when the 32 is acting alone, we can see that the current through the 4 ohm is going to be downwards. So that is going to be downwards. Therefore, the total current passing through the 4 ohm is going to be we are going to say this is IA plus I20. Now I will consider the IA to be positive because it is coming down for me. I will consider it positive, which is 32 on 7, and consider the I20 passing through the 4 as negative, which is also going to be 25 on 7. And the effect is going to be, now when you subtract 25 from 32, you are going to get 7. So that is going to be 7 on 7, and that is going to be positive 1 ampere. So the current effect passing through the 4 ohm by superposition theorem is 1 ampere. Thank you for watching this episode. It is very interesting and educative. Please subscribe to the channel, like for more videos, and check out for the next episode. See you in the next episode.